So let's talk about C++ variables. To do that, we need to talk about how memory works on a computer. So a computer RAM, or random access memory, is your short-term memory of your computer. Your computers will store a lot of data in their short-term memory just to run. Then every single program that runs on a computer takes up a certain amount of space. When you launch a program, the first thing it's going to do is allocate space and memory for that program to actually run. You can think of RAM as a stack of little boxes. Each box has an address in it in the form of a hexadecimal number. For our purposes, each box takes up 1 byte of data, so 8 bits or binary numbers. So 16 gigabytes of RAM means you have 17 billion, 179 million, so on and so forth bytes. So you have a ton of these little boxes to work with. However, we're going to stick to just these few boxes for the sake of visualizing the concept. A program, when it launches, will carve out a chunk of memory to start. If it needs more, it'll carve out more. But the question is, what happens if memory is being used by something else? Programmers will write code that will manipulate data stores in specific addresses in memory. Luckily for us, we don't have to worry about that too much, other than making sure we build some things out the proper way. Our compiler will do most of that work for us. Now, we say RAM is random access memory, which means that we can never know exactly where in memory our program will run from, but we use it to store data, right? And sometimes we store data that will take up multiple blocks. As a result, programmers use variables. Because we can't point to address 0x10 all the time as a programmer, we don't know what address we're going to have for that memory. We use variables and something called pointers to handle that part for us. Why random though? You're trying to leave class, and let's say you are late for your next class. Your grade's going to be dropped by a whole letter grade. You really need to go. Let's say your teacher, the class that you're currently in, hands you a paper saying you need to do this for homework. What do? Do you search your backpack for a folder, find it, pull it out, open it, and carefully place it inside, then put the folder back and zip the backpack up before leaving? Or do you shove it in an empty pocket and then run out the door and deal with it later? Yeah, it's faster just to shove it in your pocket and deal with it later. RAM has to be fast. Faster to store our data in a random spot. Shove the data in and move on. We track where it's at. We keep in mind where we stored the data, but we don't take time to make sure it goes to the right spot or anything like that, because that's just going to take too long. So let's talk about a variable. So a variable, which is what we use for memory allocation actually, is a location where data is stored in memory. So a variable is not actually holding anything. What it's doing is it's pointing to a location in memory where data is being stored. A variable declaration has 3 parts. You have a name, so whatever you're going to call the variable, a data type, and a value. So your data type here in this case is int, which stands for integer. Our variable name is age, and our value is 25. Now, your variable, data type, and name can't ever change, but the value can and often does. We have to know the type of data that variable will hold so that we can reserve the right amount of memory for that value. An int will take up 4 bytes for a single number. A char is 1 byte. A string needs 1 byte per character. So hello world needs 11 bytes for 11 letters. With C++, we have to know the data type ahead of time. That way we can allocate the right amount of memory. Now, the first step to declaring a variable is, well, to declare it. Doing so will reserve a spot in memory for data of that size. So by saying int age, we're telling the computer to allocate space of memory for a integer, 4 bytes, and refer to that location memory as age. When we declare a variable, the compiler looks at the data type and reserves space for that data. An int takes up 4 bytes, so we reserve 4 bytes. The second step is to assign a value to it. Here we use the assignment operator, equals sign, to store the value in memory at the location reserved for the variable. int age, then age equals 27. The first step was to reserve the space and memory like that. Then we assign a value. So here, the equal sign, important, is an assignment operator. It's not like a normal equal sign. The assignment operator equal sign is saying, store this here. We're not checking if they're equal. We're saying, store miles in a variable called name. So here we have our assigned variable. And it takes up 4 bytes, so the value is stored there. The first time you assign a value to a variable is called initializing. We initialized the variable. We declared it, which is to reserve space and memory, and then we initialize it by storing a value in it. In this case, 27. You can only declare a variable once, but you can assign to it as many times as you want to. And key part here, the location will remain the same in memory, but the value can change. If we wanted to reassign, all we have to do is just delete what's there and then store the new value in it. Now, there are some rules to work with variables. You have to declare a variable before you can use it. You can only declare a variable once. The data type must match the data that's being assigned, and you have to initialize a variable by assigning it before you can use it. But you can reassign values as much as you want. So again, you have to say what the variable name is, so it can allocate the memory. And you can't reallocate the memory that's set. You can make new variables, but you can't reallocate that same memory to a different location. You also, again, have to initialize the variable before you can actually use it, right? If you're using age without assigning a value to it, you're just going to get gibberish, and your compiler won't even let you do it. Some more rules. You can't start a variable name with a number. You can't use some keywords, so you can't name a variable int. It doesn't work that way. You can declare a variable anywhere in your work, but tend to do it at the top. And keep in mind that variable names are meant for humans. The computer does not care what you call a variable. So your variable names should be something that makes sense to the reader, to another human, to understand what you're doing. All right, now why do data types matter? Why do we have to know what that is ahead of time? Well, when we declare a variable, we have to allocate the right amount of memory for it. In this case, 4 bytes for an int. But if we try to put a string in there for boats, right? Boats has 5 letters. Each character takes up a byte. So we need 5 bytes. B-O-A-T, error, overflow. Because we want boats in there, not boat, we don't have enough space. We get an overflow error. We're trying to write on something that we can't write on, and your program's going to crash if your compiler even lets you do it, right? So we need to make sure we allocate the right amount of memory when we declare your data type. All right, so now we're going to get into something a little weird. Something called a pointer. Now, pointers exist in every programming language, but they're really prevalent in C++. Because technically speaking, a variable doesn't actually store a value. It just points to a location in memory where your data is stored. Because we have no idea where memory is actually stored, like where your data is stored, all we do is store a pointer that points to that location. So when you have a variable, your variable will hold a pointer to the address that this value is stored in. So when you declare a variable, you reserve a space in memory to hold an address. Now we're going to store in 0x00 in this address at this location, we're going to store a address for where our variable is actually at, or the data is actually at, right? When we declare, we reserve that memory. So we have this location, this chunk that's waiting for a value. This area up here is the actual variable int age. This is pointing to where the data will be stored. The data would be stored down here at this location. And then we store that actual value. At the location of 0x00, we're storing a value that has the address for where our variable's data is stored. This holds 0x20, which is this chunk down here. So when you call a variable, make it do something, right? We know that age is up here at 0x00. We look inside that memory location to get the address for where our data is actually at. So we dig in there and say, oh, well, our data is at 0x20. It's pointing to this location. Thus, we jump to that location and can read what's inside of there. Oh, hey, it's got 29. Got it. Now it uses that value. Pointers are a really big deal in C++ because once you create something in memory, it doesn't ever go away. It's always there. Unless you take steps to close it out to prevent something called a memory leak. A variable is secretly just a pointer under the hood, but we can reference and dereference that pointer in a couple different ways, which is really important when we talk about more complex data types. We'll see a few instances of this in Unreal pretty early on, actually. Now, when programming, most of the time you could ignore this pointer stuff. The compiler will handle a lot of it for you, but there's going to be a few times where it's important to understand. And if you ever get a job programming for C++ or even C# or other languages, you're going to need to know at least a little bit about pointers. All right. Now, memory leaks. When you dynamically create data, such as when a game is running, you spawn an enemy or spawn a coin or something like that. Then you delete the reference to that object, such as maybe the character dies or you destroy a coin. It does not delete the object itself. It is still stored in memory. When we allocate our memory, right? Even if you destroy the variable or you delete that object, that memory is still allocated for it unless you clear it out. If you don't clear it out, that's called a memory leak, right? The memory is still allocated and being used, but you can't access it anymore. Nothing else can use it. It's locked. You now have slowed down your computer until you reset it. Because you didn't clear this value out there, you only have 3 blocks to work with instead of the normal 8 in this case. Thus, you can't put anything else in there. Or you only put a little bit of stuff in there and have to replace it constantly in order to be able to do different things. Your computer slows down, things go bad, and it's not great, right? It stays locked. This is why with some games, if you play them for too long, your computer will eventually slow down until you reset it because there are memory leaks. Bad programming leads to memory leaks. Luckily for us though, Unreal Engine has something to prevent this. C++ does not have garbage collection by default, but Unreal does. Other languages do as well. Garbage collection is a process of clearing out any unused or unreferenced objects in memory. Because C++ does not have this built in, right, it can run faster. Because garbage collection can take time. At relatively random times, if garbage collection runs, it will slow down the computer as it's processing that. It'll pick back up and go better afterwards, but it's still going to cause like small little lurches in speed. Unreal builds in garbage collection. If you use something called the Unreal Header tool, which is really easy to use. The Unreal Header tool looks for macros that automatically generate code that lets the reflection system work. So if you look at your classes that you've made in C++ in Unreal, you'll see UCLASS there above the class name. Every variable you make has UPROPERTY. Every function you make has UFunction. And then inside of your header file for your class, you'll see something called generated body. So this last one, generated body, what this does is takes all the code that's required for a object to have garbage collection or anything else that's required for the reflection system and includes it for you right here. So you have UCLASS. This gives your reflection system knowledge that, hey, item is a class. Then it calls generated body. This pulls all the code required for this class to have the reflection system or garbage collection or anything like that. And so using the Unreal header tool is pretty straightforward because you don't actually have to do anything. In order to actually use your code in Unreal outright, you have to have these things anyways. So that's why there's going to be a little bit extra required to learn how to code in C++ for Unreal. It's the same stuff. You copy and paste it most of the time anyways. But you need to put it there so that way Unreal knows what you're doing. All right, that was a longer video, but I'm going to leave it there for right now. In the next video, we're going to start working on building out our game a little bit more. All right, that's it. Thanks.